those students, let's go over the format of your semester exam, which is going to be next Wednesday. It's the second test of the day. You're going to be in room 108 for your test. And part one has some of those prerequisite questions from earlier in the school year. You're going to have to answer 2 of the 4 problems there. And each of the 2 problems you have to answer are worth 5 points for a total of 10. Part 2, section 2, has you graphing a piecewise function and then evaluating some limits with that piecewise function. That's going to be worth 20 points. Section 3, you're going to have to then use the difference formula to evaluate a limit. There's going to be 1 question that you have to do that's worth 5 points. Section 4 is going to be giving you a graph, and then you're going to be asked to calculate some limits from that graph. And then you're going to have to do some derivatives. Section 6, doing some quote-unquote basic derivatives. You're going to answer 3 of the 4 problems, each worth 4 points. And then you're going to have to choose to do 1 of 2 problems using either the product or quotient rule. The problem is going to be worth 6 points. And then you're going to answer 2 of 3 questions that deal with higher order derivatives. Taking derivatives of derivatives, finding the second, the third derivative of a given function. Let's use that difference formula to find the limit of this function. We want to find basically the derivative of it. And we're going to do f of x plus delta x. So remember when I did these questions in class, I took out all of the x's and I substituted in x plus delta x's. So I basically do this in parts. And what I did was I substituted out all of the x's and I put in x plus delta x's in their spot. Now recall, this is going to be a hidden FOIL. You're going to have to do 5 times x plus delta x times x plus delta x. So I'm going to FOIL out. So I'm going to get x squared plus 2x delta x plus delta x squared. That's what I get when I when I FOIL x plus delta x. I still have that 5 out in front. So now what I'm going to do is I'm going to distribute that 5. So I'm going to have 5x squared plus 10x delta x plus 5 delta x squared. Now back up here, I'm going to distribute the 3. So I have plus 3x plus 3 delta x, and then I just have this minus 9. So that's the first step of doing f of x plus delta x. Now what I'm going to do is I'm going to take that, that's what f of x plus delta x is, and now I'm going to subtract f of x. I'm going to basically subtract this original function. So now I'm going to have minus 5x squared plus 3x minus 9. And I'm going to have to remember to distribute. So I'm going to have negative 5x squared minus 3x, and then make sure here this negative 9 goes to positive 9. So here's what I have, and I'm going to write it all out carefully. 5x squared plus 10x delta x plus 5 delta x squared plus 3x plus 3 delta x minus 9. So now I'm going to have 5x squared and negative 5x squared, they cancel. Negative 9 and positive 9, they cancel. And then 3x and negative 3x cancel. So I have 10x plus delta x plus 5 delta x squared plus 3 delta x left over. And then what I'm going to do is I'm going to divide that by delta x. What you want to do is you want to factor out these delta x's up top. So I'm going to have delta x factored out up top. So that's going to leave me with 10x plus, I had some graphic problems there. That leaves me with 10x plus 5 delta x plus 3 all over delta x. So now the delta x's cancel. So I have 10x plus 5 delta x plus this 3 and I'm basically going to find the limit as delta x approaches 0. Remember, you're finding the limit now, which means this delta x term is going to cancel, and that leaves me with my answer of 10x plus 3. And just recall, this limit rule is just basically finding the derivative of that function. If I go back to the original function and I find f prime, if I find its derivative, it's going to be 10x plus 3, which is basically matches my algebra. Now I want to go about finding some derivatives. So for number 3, the first thing we want to do is recall that the square root of x is the same as x to the 1/2 power. So when you're finding derivatives, what you want to do is you want to replace every radical x with x to the 1/2 power. So now when I find f prime of x, I'm going to have 6x to the first plus 4, and then just be careful here. I have minus 1/2 times 6x, and then 1/2 minus 1. So I'm going to have 6x plus 4. Negative 1/2 times 6 is 3, so minus 3x to the negative 1/2 power. And then I'm going to fix this by writing it as 6x plus 4, and then I'm going to have minus 3 over x to the 1/2 power. Remember, the negative exponent goes to the bottom as positive.
Now for this next one, here we're given a fraction, and the best way to go about finding the derivative of a fraction is to use the quotient rule. Now, there is a way to simplify this and then find the derivative. I'll do that second, but I'm going to practice here the quotient rule. U is going to be the numerator, so 5x cubed plus 4x squared minus 8x plus 3. So that makes u prime the derivative, 15x squared plus 8x minus 8. Here our denominator, v, is going to be x squared, so then v prime is going to be 2x. And for our quotient rule, what we're going to do is we're going to take the derivative of the first, so that's going to be u prime, so that's going to be 15x squared plus 8x minus 8, the derivative of the first, u prime, times v, the denominator, x squared, minus the first, u, so that's our 5x cubed plus 4x squared minus 8x plus 3, times the derivative of the second, which is just this 2x, all over the square of the second, the square of the denominator, so x squared squared. And we're going to simplify this now. We're going to distribute up top. We're going to take the x squared and distribute it, and take the 2x and distribute it. And just be careful here. I'm going to emphasize the fact that we're subtracting here. So x squared times 15x squared is 15x to the 4th. X squared times 8x is 8x to the 3rd. And then negative 8 times x squared is negative 8x squared. Here's my minus. I'm going to put the second term in parentheses. 2x times 5x to the 3rd is 10x to the 4th. 2x times 4x squared is 8x to the 3rd. 2x times negative 8 is negative 16x squared. And then 2x times 3 is 6. All over x squared squared, that's going to be x to the 4th. So now I'm going to simplify this. Up top, I have all of these terms. So 15x to the 4th plus 8x to the 3rd minus 8x squared. And now I'm going to distribute this negative. So now I'm going to have negative 10x to the 4th minus 8x to the 3rd plus 16x squared minus 6, all over that x to the 4th. I'm going to combine some like terms now. So I have 15x to the 4th minus 10x to the fourth. So that's going to give me 5x to the fourth. Up top, 8x to the third minus 8x to the third. They cancel. Negative 8x squared plus 16x squared gives me a positive 8x squared minus the 6 all over x to the fourth. So that's one acceptable form of your answer. But in math, sometimes different expressions have the same equivalence. Another way we could have approached this is brought the x to the second up top and make it negative. So it's equal to x to the negative 2 times 5x to the third plus 4x squared minus 8x plus 3. So now my denominator is gone. Now I'm going to distribute x to the negative 2. So our function, remember, you're going to be adding the exponent. So negative 2 plus 3, that's going to give me 1. So I have 5x to the first. X to the negative 2 times 4x to the positive 2 just gives me a 4. I'm going to write x to the 0 so you see what happened to it, but it's just 4. Here, x squared times negative 8x, that's going to be negative 8x to the negative 1, because negative 2 plus 1 is negative 1. And then x to the negative 2 times 3 is 3x to the negative 2. So that's our function. So now when I go about finding the derivative, here the derivative is going to be 5. Remember, this x to the 0 is just a 1, so it's not really there. And the derivative of 4 is just a 0, so that's gone. Now I'm going to have negative 1 brought to the front, so negative 1 times negative 8x, and then negative 1 minus 1 is negative 2. And then I'm going to bring the negative 2 to the front. That times positive 3x, and then negative 2 minus 1 is negative 3. So here, the derivative is going to be 5. Negative and negative is positive 8. X to the negative 2. Negative 2 times 3 is negative 6. X to the negative 3. So that's going to give me, the derivative is 5 plus 8 over x to the positive 2 minus 6 over x to the positive 3. Now, if you say to yourself, you know, these two things don't look alike. If I were to simplify this, 5x to the fourth over x to the 4, I'm going to put everything over x to the fourth, plus 8x squared over x to the fourth, minus 6x over x to the fourth. By the way, I think this negative 6x should be there. When I simplify this, I have 5 plus 8 over x squared minus 6 over x to the third, which is what I had from simplifying. So basically, your two answers that were acceptable are this, 5x to the fourth plus 8x squared minus 6x, right? Because 2x times 3 is positive 6x. And then when I distribute the negative, it's negative 6x. So there's my x. So this is one form that would be marked correct, and this is another form that would be marked correct. For number 5, again, this is another one that could be simplified by the quotient rule. Just remember, though, the square root of x is x to the 1/2 power. So what you want to do is you want to replace all of the x squareds with x to the 1/2 power. So replace this and this with x to the 1/2 power. I'm going to do this one by just simplifying. I'm now going to bring x to the 1/2 up to the top and make it negative. So I have x to the negative 1/2 times 5x to the fourth minus 6x plus 8x to the 1/2. Now we're going to carefully distribute. So we're going to have f of x is equal to 5. And remember, you add the exponents
Do it on your calculator if you have to. Negative a half plus 4, that's going to be 3.5. So x to the 7 halves. X to the negative 1 half times negative 6x, remember it's 6x to the 1, is negative 6x to the positive 1 half. And then negative 1 half, positive 1 half, that's 0, so it just disappears, so it's just 8. So that's another form of the original function. So then the derivative, 7 halves brought to the front times 5x, and then 7 halves minus 1 is 5 halves, minus, bring the 1 half to the front, 6x, and then 1 half minus 1 is negative 1 half, and the derivative of 8 is 0, so that cancels. So now I'm going to simplify, multiply these on your calculator, so it's 35 halves x to the 5 halves, and then negative 1 half times 6 is negative 3, x to the negative 1 half, and then we're going to bring the negative 1 half power to the bottom. So 3 over x to the positive 1 half. So there's your derivative for that one. And then finally in this video, when you should see a question like this, remember this is going to be a FOIL situation first. So you're going to FOIL 2x minus 5 times 2x minus 5. So you're going to get 4x squared, negative 10x, and then plus 25. So f of x is equal to 4x squared minus 20x plus 25. So then when you find the derivative, that's going to be 8x minus 20.